Today, the aim of the experiment was to discover the effect of surface area on the violence of a reaction. The result of this aim is to be determined by the comparison of intensity of each reaction or hydrogen peroxide catalyst experiment when two different surface areas with the same mass of reactant are used. For each of the two experiments, 20 ml of hydrogen peroxide and approximately 5 ml of washing detergent was added to 53.6067 grams of potassium iodide in a measuring cylinder. For each experiment, the potassium iodide acts as the catalyst for the experiment. In the first test, a compressed chunk of potassium iodide was used, giving a small surface area for the reaction to occur. For the second reaction, the potassium iodide was in powder form with separate crystals, giving a large surface area for reaction and the hydrogen peroxide. As shown in the video of the two tests, with the only differing variable the surface area of the catalyst, potassium iodide, the powder form of potassium iodide with the larger surface area has much more intense reaction as opposed to the first test in which the potassium iodide has a single chunk with reduced SA. The equation for the reaction of potassium iodide and hydrogen peroxide is as follows. While the reaction for both tests is the same, it's clear from the test that the severity of the reaction is not equal, alluding to the idea that the surface area plays an important role in the violence of the reaction. Note that potassium iodide is not part of the reaction, it is only used as a catalyst. As the hydrogen peroxide comes in contact with potassium iodide, they react, then oxygen and water is released. This water combines with the detergent to make bubbles and is expanded rapidly by the formation of oxygen gas, pushing the bubbles apart and increasing their volume to expand the foam. A larger surface area is much better as the catalyst is able to react with more substrate to create a more intense reaction, as all the other crystals can react with the hydrogen peroxide in a shorter amount of time, making for a reaction which is faster and greater in severity, as shown in the video comparison. The reaction is an exothermic reaction, giving off heat. This is evident from the steam rising from the foam. It's clear from the results of the experiment that surface area plays a large role in the speed and intensity of a reaction. Through evidence from the video, it can be concluded that as the surface area of the catalyst rises, so does the speed and severity of the reaction.